Section 3.1 is all about the graphs of quadratic functions. And so we're going to start by identifying some characteristics. The graph of a quadratic function is a shape called a parabola, and a parabola might open upward or downward. The leading coefficient a tells us which way the parabola opens, and a is the number in front of x squared. So when a is positive, the parabola opens upward, and when a is negative, the parabola opens downward. Parabolas always have either a maximum point or a minimum point, and this is called the vertex. If the parabola opens upward, then the vertex will be a minimum point or a low point on the graph, and if the parabola opens downward, then the vertex will be a maximum point. A parabola also has a line of symmetry called the axis of symmetry. It's symmetric around the axis of symmetry, and the axis of symmetry is a vertical line that goes through the vertex of the parabola. And this picture is in your textbook. This is a nice summary of all of that information. So the first type of quadratic equation that we're going to graph is a quadratic equation in what is called standard form. Some textbooks will call this vertex form, but our textbook uses the term standard form. And standard form is f of x equals a times x minus h squared plus k. And the nice thing about standard form is it tells us what the vertex is. So the h in the equation is going to be a number. That's going to be the x-coordinate of the vertex. The k is also going to be a number. That's going to be the y-coordinate of the vertex. So that's going to be really easy to find. So when we're graphing a quadratic function in standard form, what we're going to do first is plot the vertex. And I'm doing this a little bit differently from the book. The book has a lot more steps in graphing, but because we're going to be doing the graphs in MyLab Math, I'm going to follow the steps that you're going to need to do when you're doing the graphs in MyLab Math. So they're always going to have you plot the vertex first, and so you should get in the habit of finding that point first. Now, an important thing to be aware of is when you're finding the values for h and k, the standard form function has a negative sign in front of h. And so h, when you basically pull it out to find the x-coordinate, you're going to be taking the opposite sign. So if there's a minus sign in the function, like you see right here, this is x minus 3, that means that my h value is going to be positive 3. If there were a plus sign in the function, then my h value is going to be negative. The value of k will have the same sign because there's a plus sign in front of k. So just something to be aware of. And then the second step when it comes to doing the graph is to find the y-intercept. Now, according to MyLab Math, you could also find the x-intercept, but it's usually easiest to find the y-intercept, and we're going to make things easy on ourselves and do this in the easiest way possible. So we find the y-intercept by plugging in 0 for x, and then just a little bit of math will give us the value for that. So we're going to do example 1 from the textbook. It says to graph the quadratic function f of x equals negative 2 times x minus 3 squared plus 8. So my first step is to identify the vertex. So looking at this function, the x-coordinate is going to be positive 3. Opposite sign for that, because there's a minus sign in the function. My y-coordinate is going to be positive 8. We use the same sign for the y. So my vertex is 3, 8. So I can go and plot that. That's going to be right here. Now for my second point, the y-intercept, I'm going to plug in 0 for x into the function. So negative 2 times 0 minus 3 squared plus 8. Then I just need to do that math. Now, you might have a calculator where you can just type this in and it will give you the right answer. If not, it's just a little bit of work with order of operations. I need to do the parentheses first, so 0 minus 3, which is negative 3. And then I need to do the exponents. Now be careful. Negative 3 squared is positive 9. Negative 2 times 9 would come next. That's negative 18. And negative 18 plus 8 is negative 10. Now this is the y-intercept, which means I'm plotting it on the y-axis. So right down here. Now when you're doing this in the homework, what's going to happen is once you click on the vertex, it's going to fill in the parabola shape for you, and then you just need to click on the y-intercept to lock that parabola shape down. If I'm trying to draw it by hand, it's a little bit more difficult. I'm going to apologize right now for this. This probably, isn't going to look that great, but I'm going to do the best I can. It's going to look something like that. And then on the homework, like I said, it'll look a lot better because my lab will do the hard work for you. Now, the other thing that's on the homework is they're going to have you fill in the axis of symmetry, the domain, and the range. Now, the axis of symmetry is always a vertical line that goes through the vertex. So it's going to be this dotted line here. My graph is obviously not very good because it's supposed to be symmetric around that line. And the line always has the equation x equals whatever the x-coordinate of the vertex is. So this one is x equals 3. Now be careful because when we've been solving, we've been entering answers where we don't put the x equals. But for this, the axis of symmetry is a line, and so they want you to put in an equation, so you need to put the x equals in order to get the problem correct. Domain and range. Well, for domain, we have arrows here on both sides, and that means the function is going to continue forever in both directions. For any parabola or any quadratic function, my domain is always negative infinity to infinity. And remember, when we're doing domain and range, we always use parentheses around infinities and negative infinities. So you'll always put the same thing in for the domain no matter what the graph of the parabola looks like. Now for the range, this graph is going everything negative up to 8. 8 is the highest point. So my range is going to be negative infinity to 8. On negative infinity, I have a parenthesis because I always have parentheses around the infinities. Around 8, I'm going to have a bracket because 8 is included. There is a point here, it's a solid dot, and so that's included on the graph. So that would be my range. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. Next, we're going to look at example 2. Same idea, we're going to graph the quadratic function here. So first I need to find the vertex. For this one, the vertex is going to be negative 3 for the x-coordinate, opposite sign for x, same sign for y. So the vertex is negative 3, 1. Now for I'll plot that real quick. For my y-intercept, I'm going to plug in 0. So we have 0 plus 3 squared plus 1. 0 plus 3 is 3. 3 squared is 9, and 9 plus 1 is 10. So my y-intercept is 10. Now this parabola, this is the vertex, this one's going to be opening upward. So drawing the shape as best that I can. And we know that it's opening upward as well. If you go back to what the standard form looks like, where the a value appears in the standard form is in front of the set of parentheses. So because we have the parentheses and we don't just have an x squared term and an x term, the a is in front of the parentheses. So when we looked at example 1, My a here was -2, and so that's negative. That means the parabola opens downward. For example 2, there's no number or negative sign in front of the parentheses, and so that means that it is positive. So positive means that the parabola is going to open upward. So lastly, I'm going to fill in here my axis of symmetry, domain, and range. So axis of symmetry is x equals x-coordinate of the vertex, which is -3. My domain is always -infinity to infinity for these parabolas. And lastly, the range. Now for this parabola, we have our y-coordinates are everything from 1 up to infinity. Remember, with range, you're looking at the y-axis. Domain, you're looking at the x-axis. So my range here is 1 up to infinity. I'm including 1, so square bracket around the 1, and then always parenthesis around the infinity symbol. So that's what the graph of example 2 will look like. Next, you should do checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the video. At the end here, I have a quick summary of finding the axis of symmetry, domain, and range for parabolas. Axis of symmetry is always x equals the x-coordinate of the vertex. Make sure you include the x equals. Domain is always -infinity to infinity. And then the range depends on whether the parabola opens upward or downward. Y-coordinate of the vertex to infinity if it opens upward, -infinity to the y-coordinate of the vertex if it opens downward, and then we always use a square bracket around the vertex because that point is always included.